AP Cram, Calculus AB, Free Response Exam Review. Question 45. Particular solution to a differential equation, U-Substitution. Consider the differential equation dy dx is equivalent to 3 minus y times the cosine of x. Let y be equivalent to f of x be the particular solution to the differential equation with the initial condition f of 0 is equivalent to 1. The function f is defined for all real numbers. Find y is equivalent to f of x, the particular solution to the differential equation with the initial condition f of 0 is equivalent to 1. So here we're asked to find the particular solution based on an input of x yields an f of 0 of 1 or a y that is equivalent to 1. All right, so I'll give you a moment to think about your strategy. And the solution does require sequential mathematical steps. Some of you might be familiar with some of these and some of you may not. So that's totally fine. All right, so the solution to this is not so bad. It's just very sequential and it requires a few steps of algebraic manipulation. So here we have our differential equation dy dx is equivalent to 3 minus y times the cosine of x. And we're going to solve this by separation of variables. Therefore, we separate by placing everything with the variable y on the left-hand side and everything with the variable x on the right-hand side. Okay, and now we're going to integrate. And after integration, we get the negative natural log of the absolute value of 3 minus y is equivalent to the sine of x plus c. But just in case you're wondering how we got this from this, because most people know that when you integrate cosine of x, you get sine of x. Let's just explain this. The integration of a fraction with an expression in the denominator and a 1 in the numerator. So we have the integral of 1 over 3 minus y dy. That's the same thing as writing dy over 3 minus y. Okay. And when we go ahead and integrate that, we get negative the integral of 1 over u du. And we had to perform u substitution. U becomes 3 minus y, therefore du becomes negative y, because if we were to take the derivative of this, it would be, well, the constant is eliminated, and then the derivative of y with respect to y is going to be just 1. So you get a negative 1 dy. So du becomes negative dy. Okay, so that's where the negative sign comes from. All right, so when you take the integral of 1 over a variable, you get the log, the natural log, that is, of that variable plus c plus a constant, and we still have to incorporate the negative sign that we got from u substitution when we kind of use the chain rule to integrate negative y. Okay, so then when we back substitute for u, we get the negative log with, this is the natural log base e, which can also be expressed as the negative ln of 3 minus y plus a constant. The reason why you don't see a constant here on the left-hand side is because we subtracted c over to the right-hand side so that all our constants are just with x terms. And when you subtract a constant from a constant, you just get a constant. So there's no need to write it double time, okay? And expressing it on the right-hand side is just a matter of preference, all right? Okay. So when we plug in our initial condition of f of 0 equals 1, we obviously have to substitute 0 for x and then 1 for y. And the absolute value of 3 minus 1 is going to be the absolute value of 2, and the absolute value of 2 is going to be 2. So the negative ln of 2 is equivalent to the sine of 0 plus c. The sine of 0 is just 0, therefore c is equal to the natural log of 2. Now we can back substitute now that we solve for our constant. And so the entire expression becomes the negative natural log of 3 minus y equals the sine of x minus the natural log of 2. And note, this is the absolute value, okay? All right. So what we have to do now is going to get a little hairy, but just bear with me. First, we want to get rid of this negative sign. So we divide through by -1, and then we're left with negative sine of x is equivalent to, we're left with the ln of the absolute value of 3 minus y is equivalent to the negative sine of x plus the natural log of 2. But now we also want to kind of get rid of this absolute value sign because it's kind of tricky. So because our initial condition says that y of 0 equals 1, y is therefore less than 3. That is, 1 is less than 3, or f of 0 is less than 3. So the absolute value of 3 minus y will always be the positive half of that absolute value. It's never going to be like a negative number where you'll have to undo the negative sign of the absolute value, okay? Therefore, the expression becomes this. But just in case you're wondering how it became this, let's take a little detour. All right, so to get rid of the natural log after we divided through by -1, this becomes a negative, this becomes a positive. We take the exponent of both sides, okay, in order to get rid of the natural log on the left-hand side. And so we have e to the sine, e raised to the negative sine of x plus the natural log of 2 that's supposed to be a 2 over root of e. Now what we can do is separate this, and we end up with e to the negative sine x times e to the natural log of 2. And now we have the same base, and when it's negative, that can just be written in the denominator. So that can just become e to the natural log of 2 over e to the sine of x. Okay, we got rid of that negative sign. But we know that raising a natural log to the exponent cancels out the natural log. Raising the base e to a natural log cancels out the natural log, and whatever's in the natural log expression can just be written out front as a constant. So this becomes 2 over e to the sine of x. But if we want to bring this base e back up to the numerator, it can then become 2 times e to the negative sine of x, okay? So just a few sequential exponent steps, but that's where that comes from. So, all right, back to business. We left off at this point before our little detour. Now, if we isolate y on the left-hand side, this becomes y is equivalent to 3 minus 2e to the negative sine x, okay? And that's our solution. And the solution is valid, again, for all real numbers. So our domain is all